Okay, we're doing the review for 8.2, and the first question is write r equals 4 over 1 minus cosine of theta using rectangular coordinates. Well, we know that r equals the square root of x squared plus y squared, and cosine of theta equals x over r. So now we've got, I'll leave r as r, and 4 over 1 minus x over r. And now let's get a common denominator, and that's going to be r, so we get 4, and when we get that common denominator and add them up, we wind up with this. So now we'll invert and multiply, and we have r equals 4r over r minus x. And now let's divide both sides by r, and if we do that, the r's divide out here and here. So we just have 1 equals 4 over r minus x. Now let's multiply both sides by r minus x, and if we do that, we have r minus x equals 4, so r equals x plus 4. Well, let's keep going with that. Now we'll replace r with its identity, and we have the square root of x squared plus y squared equals x plus 4. So let's square both sides, and if we do that, we get x squared plus y squared equals, and if we square this side, we get x squared plus 8x plus 16. Now subtract x squared from both sides, and what we have left is y squared equals 8x plus 16. We could factor a 4 out of both those terms, and so we have y squared equals 4 times x plus, plus 2x plus 4. So y equals plus or minus, the square root of 4 is 2, and the square root of this stuff is 2x plus 4. And we're done. We've tackled it. Now for question 2, we have to graph this and identify it. And one thing we're going to rely on here is symmetry, and the discussion on symmetry, the boxed item is on page 599. So let's make a little list of values for r as it's related to theta. So if theta is, for example, pi over 2, sine of pi over 2 is 1, and 1 plus 2 is 3, the radius will be 3. What if it's pi over 3? Well, that's the square root of 3 over, sine of pi over 3 is the square root of 3 over 2, which is approximately 0.85. So 2 plus 0.85. 0.85. And what if theta is pi over 4? We'd have sine of pi over 4 is root 2 over 2, and root 2 over 2 is about 0.7, so we have 2.7. At pi over 6, sine of pi over 6 is 1/2, so we'll get about 2.5 for radius. If you're talking 0, the radius will be 2. Now, if you go to negative pi over 6, what we get is 2 minus 0.7, which will be 1.3. If you go to negative pi, I beg your pardon, did I do that right? No, 2 minus 1/2, which will be 1.5. If you go to negative pi over 4, that'll be 2 minus 0.7, which is 1.3. If you go to negative pi over 3, you'll be 2 minus 0.85, which will be 1.15. And at negative 3 pi, or negative pi over 2, that's negative 1, and 2 minus 1 is 1. So now, I am only concerned with the right side of this because this figure is symmetric about the y-axis, and you can see why when you go to page 599. So we'll make a rough graph of this. And so let's see, we'll start about here. And so at pi over 2, when the angle's pi over 2, we're at 3. So this, when the angle, and let's look at these angles. Pi over 2, pi over 4, pi over 3, pi over 6, pi, let's see, negative pi over 6, negative pi over 4, negative pi over 3. Okay, for pi over 3 will be at 2.85, for pi over 4 will be at 2.7, for pi over 6 will be at 2.5, for pi over, for 0 will be at 2, then we'll be at 1.5, 1.3, 1.15, 1, and this is what it looks like. And it turns out the other side's going to look the same way because it's symmetric about the y-axis. And this is what's called a limicon on con without an inner loop. An inner loop. And the easy way to do this is go to page 606, and you can use the table, and it gives the general shapes on that table. And